Hello. This video is designed to help you understand what to do when trying to find the derivative of a certain function. Functions can be written in many different ways, and this video will help you identify when to use derivative rules versus when to rewrite a function first so that you can use derivative rules more easily later. Before we begin, I'd like to note that this video will focus on more complicated derivative rules like the product and quotient rule as opposed to more basic fundamentals like the sum rule or constant multiple rule. Before watching this video, make sure you're familiar with the basics of derivatives so you can focus on what's happening here. So let's start off with the product rule and the quotient rule. All of these formulas will be given to you on a formula sheet for Business 4000, so you don't have to remember them, but you should probably have enough practice with them that you wind up memorizing them anyway. One of the things you might notice about both of these rules is that they involve an f of x, a g of x, as well as an f prime of x, and finally a g prime of x. The important thing to note here is that there are two functions of x, which we'll call f of x and g of x. Let's start with this example. Say you want to find the derivative of f of x equals 2x to the third times 5x plus 7. You could say that this function has two parts to it. The first part is this 2x to the third, which is then being multiplied by the second part, 5x plus 7. The important thing to notice is that there's an x in both of these parts. Wouldn't you agree that this looks like two separate functions being multiplied together? This function of x being multiplied by that function of x? That's what you can think of this as, and that's why the product rule formula looks the way it does. Looking back at the formula, it looks like we're taking the derivative of two functions of x being multiplied together. We'll call this first term f of x, and we'll call this other term g of x. Again, the important thing to note here is that both of these functions have an x in them. That's how you know when you should use the product rule. If you don't see an x in both of these terms, like in this example here where I just took the x cubed away, you shouldn't be using the product rule. We'll talk about what to do in that scenario a little bit later, but for now, just know that in order to use the product rule, you should see an x in both of these parts. Looking back at our example, since there is an x in both of those terms, we can use the product rule. We know our f of x and our g of x, and we can easily find f prime and g prime of x. Now we can put all the pieces of the puzzle back together to get our final answer. In case you didn't know, you can type this answer as is into WebAssign without simplifying it. Going back to what I said earlier, let's look at an example where you shouldn't be using the product rule and instead should rewrite or simplify the function before finding its derivative. Here, if you realize that this can be rewritten by taking away the parentheses around the 2, you're already on the right path for solving this. By distributing this 2, I'm left with 10x plus 14, and from there I know the derivative f prime of x is just 10. To answer the question, you shouldn't use the product rule if you don't see an x somewhere in both of the things you're multiplying together. Here are some examples of when to correctly use the product rule and some examples of when to rewrite the function. Now, let's take a look at when to use the quotient rule. It looks similar to the product rule because it involves four pieces to the puzzle, an f of x, a g of x, an f prime of x, and a g prime of x. I find that it helps whenever you're using the product rule or the quotient rule to write out those four puzzle pieces so it's easier to put them together later. So here are the four pieces I know I'll need. For our example, say I'm trying to take the derivative of this function, 4x squared minus x divided by 15x. Like the product rule, this function looks like it has two parts to it. The first part is this 4x squared minus x, and the second part is the 15x. I see an x in both of these parts, which means I should be using the quotient rule. That's the key. I know I should be using the quotient rule if I see an x in both the numerator and the denominator. We'll cover scenarios where we're missing an x in either the numerator or denominator after this example. Notice that in these two examples, neither of them have an x in both their numerator and denominator. But getting back to our example, since I know I'm using the quotient rule here, I'll call the numerator f of x, and I'll call the denominator g of x. From there, it's easy enough to find f prime of x and g prime of x. We now have all four pieces of the quotient rule ready to piece together. Our derivative then looks like this. Again, you can leave your answer like this without simplifying it for WebAssign. Now let's cover some examples where we shouldn't be using the quotient rule and instead should rewrite the problem and then use a different derivative rule from there. We'll use the examples we saw earlier. In the first example, I can get rid of the fraction and the square root, which is generally problematic to work with. We want to get rid of those by moving this 4x plus 5 to the numerator and giving it an exponent of negative 1/2. The exponent is negative because we moved the 4x plus 5 from the denominator to the numerator, and it's 1/2 because we took away the square root and replaced it with that 1/2. From here, we can use the general power rule to find our derivative. This answer, like our others, can be simplified, but you don't have to for WebAssign. In the other example, we're missing an x from the denominator, so we'll need to rewrite this function before finding its derivative. I can separate this fraction into two pieces, making sure that they both have the same denominator of 50. Now, it probably seems a bit more obvious how to find the derivative from here. We use the power rule for this 1/50th times x to the 5th part, which becomes 5 over 50 times x to the 4th. The other term, the 300 over 50, just falls to 0 because there's no x in it. I think you'll know what I'll say about the simplification here. Summarizing what we've done here, in both scenarios, we noticed that there wasn't an x in the numerator and denominator. So, in order to use a different derivative rule, we rewrote the function. Then we were able to see a different derivative rule to use and applied it to our function. To wrap up, let's look at what we're looking for in order to use the product rule or the quotient rule. For the product rule, I'm looking for an x in both of these parts, or in other words, two functions, both with x in them being multiplied together. If that is the case, as it is in these examples below, then you are good to use the product rule. Likewise, for the quotient rule, we're looking for an x somewhere in both the numerator and the denominator. If that's the case, like in these examples, then go ahead and use the quotient rule. I hope this helped. Good luck in Business 4000.